Database normalization organizes the structure of your tables to increase efficiency and performance. We do this by adhering to standards known as normal forms. In essence, the higher the form, the more constraints are imposed on the database tables. The forms are guidelines for normalizing your database and serve somewhat like a checklist. There are many benefits, including saving space, faster queries, and things like making changes and retaining information becomes easier. So what are the forms of database normalization? It is widely accepted that there are 6 normal forms: the first, second, and third normal forms, followed by the Boyce-Codd normal form, and then the fourth and fifth normal forms. However, there are a total of 9 normal forms if we include the elementary key normal form, the domain key normal form, and the 6th normal form, all of which are generally associated with one of the other normal forms. In a well-designed database, you will typically find yourself using the 3rd normal form. Any higher normal forms are usually used on a need-by-need basis. The elementary key, also called the Boyce-Codd normal form, is usually considered a slight improvement on the 3rd normal form, and is only used if there is more than one unique composite key in a table and they overlap. The domain key normal form and the 6th normal form are usually interchangeable. Today, I'll be talking about the 3 most widely used normal forms. To be in first normal form, we need to follow 2 rules. The first rule is that each column must contain only atomic values. So what is an atomic value? An atomic value might make you think of something you learned years ago in science class, but when we're talking about databases, an atomic value is the most simplified piece of data in your database table. So what does this mean? Well, let's take a look at a user's name. You might be able to argue that a full name is still just one name, but the atomic values of a full name is the first name, middle name, and last name. Each column should have an atomic value. That is, it stores one piece of data. At the end of the day, full name is still storing 3 names, and to be in first normal form, we need each column to store one thing. And that brings us to the second rule of first normal form. There are no repeating groups. Let's look at this example. You can see the department column only has one value, but those values are repeating multiple times. We can take that and store it in another table, using a relationship to link the 2 together. Now we're in first normal form. Each of the normal forms cascade on one another, meaning that to be in a higher normal form, you need to first satisfy the requirements of the lower normal forms. That being said, you may end up being at third normal form on your first try, so it isn't exactly sequential or in order. It just has to satisfy the requirements of the other normal forms. To be in second normal form, we have an additional set of rules. The first rule is that your database is already in first normal form. The second rule is that all non-key attributes are fully functional, dependent on the primary key. To understand this, we need to know what a non-key attribute is and what it means to be fully functional, dependent on the primary key. We already know what a primary key is, so what is a non-key attribute? A non-key attribute is any attribute in the table that is not a primary or composite key. So what does it mean to be fully functional, dependent on the primary key? This really only applies to a composite key, in which case all the non-key attributes have to be dependent on all parts of the key. If there is only one primary key, then the table is already in second normal form. Take a look at this example. We have a student ID and a course ID, but neither of them can uniquely identify any single row in the table. However, we can use both of the IDs together to create a composite key, which by itself can become our primary key. To be in second normal form, we now need to determine if the non-key attributes are dependent on the composite key we just created. Let's take a look at the student's name. The student's name is dependent on the student ID, but in order to be in second normal form, it has to be dependent on both the student ID and the course ID. Since it is not dependent on the course ID, we can move this attribute to another table called students. Next, let's have a look at the course name. The course name is dependent on the course ID, but like the student name, it is not dependent on the student ID. We can move this in a table called courses. And last, we have the grade column. The grade column is dependent on both the student ID and the course ID, so it can remain here in the student courses table. Now the database is in second normal form. Keep in mind that your database may already be in third normal form at this point, and you might not need to change anything. If you've been following the first and second normal forms, then your database may already adhere to the standards of the third normal form, so just keep that in mind. To be in third normal form, we have yet another set of rules. Like the second normal form, the first rule is that your database is already in second normal form. The second rule is that there are no transitive functional dependencies. So again, you might be asking, well, what is a transitive dependency? And you'll find that the higher the form, the more vocabulary is involved. A transitive dependency is a dependency that exists between any of our non-key attributes. For example, let's have a look at this table. Let's say the customer ID is our primary key, and all the other keys are just our non-key attributes. We want to make sure there are no dependencies in those non-key attributes. First name, last name, and zip code are all dependent on customer ID, which is fine. However, city is dependent on the zip code. If we have the zip code, we can store the city in a separate table, called postal codes, and now our table is in third normal form. Not so hard, is it? Well, this is where it starts getting complicated. So far, all the forms that we've covered dealt with functional dependency. The Boyce Codd normal form focuses on eliminating all forms of functional dependency and is used if you have two overlapping candidate keys. The fourth, fifth, and sixth normal forms begin to deal with multi-valued dependencies and are rarely used. I won't go too much into these. As I said, these would be used rarely on a case-by-case basis, and there's a lot to cover in regards to the way the relationships start working at this point. Also, due to the increasing complexity of the database structure, we start utilizing relational algebra more and more frequently, and is really best saved for the more advanced. The third normal form is the most widely used normal form in relational databases today. Even people who aren't familiar with functional dependencies can be found using the third normal form correctly. Think about the projects we've done in lab where we've normalized our tables. Most of these are actually in third normal form. And now it's up to you to figure out how you can apply this to your databases from here on out.